Let's learn some vocabularies for quadratic functions. First, vertex. What is the vertex of a quadratic function? Well, the word vertex means peak. So the vertex of a quadratic function is the peak point on a parabola, which means for a parabola opening down, the vertex is the highest point. Now, for a parabola opening up, the vertex is the lowest point. So in this case, we have a parabola opening up. So the vertex is the lowest point right here, sitting at x equals 1, y equals -9. So the vertex is at 1 and -9. Next, axis of symmetry. The axis of symmetry of a quadratic function is a vertical line that divides the parabola into two equal halves, like this. And the axis of symmetry must always pass through the vertex. The symmetry behavior can be best understood when we fold the parabola in half along the axis of symmetry. Then the right half of the parabola will completely overlap the left half of the parabola. Can you see that? Let me show you. Here we have a parabola just like this one. And the axis of symmetry runs down the middle of the parabola. Now I'm going to fold the graph along the axis of symmetry. Can you see that? The two halves of the parabola completely overlap each other. Yeah? Cool. Now let's determine the equation of the axis of symmetry. For a vertical line that passes through x equals 1, the equation of the line is simply x equals 1. Because for every point on this vertical line, the x-coordinate is always 1. So in this case, the equation of the axis of symmetry is x equals 1. Next, y-intercept. The y-intercept is the point where the parabola intersects the y-axis. So in this case, that's right here. And then the y-intercept is -8. Next, x-intercepts. The x-intercepts are the points where the parabola intersects the x-axis. So in this case, the parabola intersects the x-axis at 2 points. One at x equals -2. Another one at x equals 4. Next, domain. By definition, domain is the set of x values for which a function is defined. So as we can see, a parabola is defined for all x values. Let me show you. This point, the x value is +1. This point, x value is +2. This point, x value is +3. This point, x value is +4. This point, x value is +5. So a parabola is defined for all positive integers for x. Now, if you take any points in between, now see, these points, the x values are positive decimal numbers, right? Yeah. So a parabola can take on any positive values for x, whether they are integers, whether they are decimal numbers. Parabola can take on any positive numbers for x. Now, guess what? Parabola can also take on any negative values for x. For example, this point, x value is -1. This point, x value is -2. This point, x value is -3. See, negative integers. Now, for any points in between them, for any points between the negative integers. See, these points, the x values are all negative decimal numbers. So in conclusion, parabola can take on any positive values for x. Parabola can also take on any negative values for x. And parabola can even take on 0 for x. That would be this point. See, for the y-intercept, the x value is 0, right? So therefore, the domain for a quadratic function is all real numbers. And we write a mathematical notation like this. X is all real numbers. Right? This symbol means is. And this symbol here represents, see, this symbol here is an R with an extra bar, represents all real numbers. In fact, the domain for any quadratic function is always x is all real numbers. Next, range. By definition, range is the set of y values for which a function is defined. So here, the parabola only go as low as right here, where the y value is -9. However, it will go as high as it likes. And therefore, we say the range talks about y, right? So the range is y must be -9 and anything above. So the range is y is greater than or equal to -9. Does this parabola have a minimum value or a maximum value? Well, first of all, in math, whenever we talk about the value of a function, we are always referring to the y value. Remember that. Value of a function always refers to the y value. Now, since the parabola can go as high as it likes, there's no maximum value. However, parabola can only go as low as right here, where the y value is -9. Therefore, we say this parabola has a minimum value of -9.